Hello people, so today we'll be solving to daily question, that is 1590 makes sum divisible by p, and in this we'll be given an array of positive integers nums, and we have to remove the smallest subarray, which can be possibly empty, such that the sum of the remaining elements is divisible by p, and it is not allowed to remove the whole array, and we have to return the length of the smallest subarray that we need to remove, or -1 if it's impossible. Okay, and then we have a subarray is defined as the contiguous block of elements in the array. For example, we are having an array nums and p is equal to 6. So we need to make the sum of the array to be divisible by 6. Okay, so for that the initial sum, which if we calculate, comes out to be 3 plus 1, uh, 4, 4 plus 4, 8, and 8 plus 2, 10. Okay, so to make it divisible by 6, we need to cut the sum down to 6. So what we can do, we can just remove this 4 and our sum will become 6 of the whole array, which is clearly divisible by 6, or let's say p. So the smallest subarray which we need to remove is 1. Okay, so this is what we have to basically solve in the question. And now let's have a variable which is, okay, so for this, let's have initially some variable. Oh, pretty bad. Let's have some variable that is initially 0, and we'll be obtaining the sum based on the like whenever we add a number, we'll be doing a mod of it with p. Okay, so for int num in nums, I'll be doing sum will be equal to, oh, or let's just do sum plus equal to, ah, okay, sum equal to sum plus num. Hmm. Sum plus num mod p. Okay. Now let's have the final mod as well. So in mod which we need to remove, basically you can say, because this will be the exactly value which we need to remove from the sum, and then our sum will then our array will become divisible. Sum of the array will become divisible by. Okay. So this, and we'll be checking that if mod comes out to be 0, means that the array is already divisible. In this case, we'll be returning 0. Okay, so now let's have an answer which can be of the maximum value, that is of length of the nums. Okay, now let's traverse. We also need a hash map of integer. In this, basically we'll be storing the mod along with the respective index where we have found that particular mod. Okay, integer comma integer, so let's call it map, that is equal to a new hash map. Okay, now let's traverse and also initialize the sum in a map to be map dot put 0 comma -1. Okay, now let's traverse in the array for int I equal to 0, I less than nums dot length I plus plus. Okay, now and let's also have a current sum mod, basically int cur, that is initially 0 only. Okay, and now what I'll be doing is I'll be updating my current sum, just I did over here. So I'll be updating my current equal to current plus num mod p, and now I'll be finding the required mod which should be present in the map so that we can fetch our answer. Okay, so int required, let's call it rec only, so that will be equal to my current mod minus the overall mod, doing a mod of it with, oh sorry, adding p to it, and then doing a whole mod of it with p. Okay, and then I'll be checking that if map dot contains key the required mod, I'll be updating my answer as minimum of my current answer comma I minus current index minus map dot get the required mod plus no, okay, we just need the length, so this will be enough. And then I'll be updating putting the current mod along with its index in the map, so int current comma I. Okay, and at the end I'll be returning, but before checking that if my answer is equal to length of the nums, then -1, otherwise I'll be returning answer. Now let's give it a run. Oh, cannot find symbol. Which symbol cannot find? Oh, nums I. And it gets skipped. Now let's submit it, and it works perfectly fine as well. Okay, so just for today, thank you for watching.